Today we are going to learn to build, expose, and debug an MCP service. If you think that's intimidating, well, let's see what we can do in 5 minutes using Orkes Conductor. Consider a customer support ticket creation flow. A workflow orchestrates the steps required to create the ticket. The output of that would be the ticket created with, say, a corresponding identifier. A route then exposes an endpoint that triggers this workflow. And the route is grouped within an Orkes service, and that service packages related ticket APIs for external access. And then we need a schema, which defines and validates the ticket fields like a title, description, priority, and user information. And then we'll also need to configure API authentication that ensures only authorized clients can invoke the service to create tickets in the first place. And then the killer feature here will be an MCP gateway. That will expose this whole ticket route as an MCP tool that AI agents can discover and call. And then finally, we'll use the Orkes MCP workbench to provide a developer interface to test and debug this whole ticket creation tooling. We'll start by creating an Orkes workflow. Now, for now, what the Orkes workflow does is quite simple. It simply takes as input details like the username, description, ticket priority, the problem, and then pseudo-randomly generates a ticket identifier to go with the case. We'll next create a schema. Now, the schema is critical because it gates in front of the workflow a particular way of submitting the data. If the data is not submitted in the form enforced by the schema, the workflow won't even execute. And this is really important to ensure that expensive tooling like AI agents don't waste their time processing requests that aren't even formed properly in the first place. Notice as well that each of these components we're making act as building blocks that can be independently restructured. We can adjust the configuration of them, and they can be independently versioned. We're now going to set up authentication to the service we end up creating. For now, we're going to be okay with basic credential-less auth, but in any real prod system, you'd want to set up API or token-based authentication. The next step is creating a service. Here we'll set a name, the allowed connection parameters, and the endpoint that will be used to connect. Critically as well, here we see we have MCP enabled. Orkes automatically exposes the service as an endpoint that Model Context Protocol tooling can connect to. No additional configuration needed from our side. We'll then create a route, which is a specific endpoint in our service, here we'll call it create, to then our create ticket workflow, all enforced by our schema. So the route will connect our service to our workflow, with the schema acting as an enforcement mechanism. This also provides a good opportunity to test that our endpoint triggers the workflow and the execution behaves as expected. That is, it takes in these inputs and then produces a auto-generated ticket ID as the output. With all that in place, we can next add our MCP endpoint as a connection source in MCP Workbench. This tool allows us to validate our schema, expose parameters, as well as debug any issues with the payload. We connect to the MCP URL exposed by Conductor, and then voila, we see a JSON schema returned, as well as our input schema exposed as a tool we can interact with in Workbench. So let's test this. We put in the parameters as defined by our input schema. This is ultimately the input to the workflow we created. And then if we run it, that should result in a workflow execution that outputs a ticket ID. And it looks like, in fact, that is what happened. We can validate this in Orkes directly as well. If we look at the workflow execution and we look at the trace, here is the input, here is the output, the ticket ID matches, it performed as expected. Let's now test schema validation. Remember, a big goal here is to not execute the workflow if the inputs aren't properly formatted. For example, if we don't include enough information, we get a schema error. And looking at the workflow, a new workflow never executes, saving us on compute time. So the schema acts as a hard gateway to ensure that only correct input is allowed to execute the workflow. Now, let's tack on a treat at the end. Orkes supports integration with large language models. We can incorporate them as AI prompts into our workflows. Here, we create an AI prompt integrated with OpenAI's 4.0 model. Then we make that the first task in our workflow, so users can interact with our workflow via natural language. That task, the model, then processes that input into the schema we want, And that then gets passed to our ticket creation task. So we still end up with our properly formatted schema. It's just we're relying on an AI agent to do some of the interpretation of the user's prompt. But our schema, route, service, endpoints, they don't need to change. We rely on Orkes Conductor's modularity and abstractions to manage the whole process.